Hello everyone and welcome back to Diksha Karnataka YouTube channel. And today we are starting with our KCET 60 out of 60 series. This is the video number 1, and if you have not seen our launch video, we have already done a launch video with detailed explanation what all we are going to do. I am giving you a brief introduction before we are starting our first topic of the day, because this is the first video. So what all we are going to do then in this KCET 60 out of 60 series physics? First of all, we are going to discuss all the chapters, all the concepts specifically for KCET exam. So if you are preparing for KCET 2025 exam, so you have to see all the lectures, all the notes will be provided end of the lecture. All the videos will be live at 9 p.m. Whatever day it is going on live, maybe today it is going on at 9 p.m., tomorrow it is 9 p.m., maybe day after tomorrow again 9 p.m. But whenever it is going on live, it will always be available on our Diksha Karnataka YouTube channel in a separate playlist. So anytime you can go there, you can check and you can see through the lecture. So it will be live. So some students are asking when it will be live. It will be live 9 p.m. every day. Okay. Also, there will be a separate playlist. Yes, for physics there will be a separate playlist. For other subjects also there will be a separate playlist available to you, so that you can check and learn from those videos. Next, what all we are going to do in this series, we will obviously go through the lectures of concepts. We will solve previous year questions. Yes, we will solve previous year questions separately, chapter wise. As soon as the chapter is over, we will solve some important chapter wise questions from this chapter. What all we are going to do, very important part is we will give you a test series every Sunday 10 a.m. in the morning. Okay, 10 a.m. in the morning you will get the question paper. You have entire day to solve the paper. In the evening around 5 or 6, the answers will be provided to you. So you have the entire day. Sit down for some 30 minutes, 1 hour, try to solve those questions, and in the evening we are going to discuss all the questions in detail. So that will also be there. We are saying this is KCET Premier League, KPL Physics. Now how you can attend those test series? It is absolutely free, and you can join them by joining our WhatsApp group. The link is given in the description below of the video, and it will be there in each on every lecture. So don't miss to join our WhatsApp group, where we will be discussing. You can will be giving the lecture notes. All the lectures that we are discussing here, it will be given in a form of note as well. So don't forget to join our WhatsApp group. Also, if you have not yet subscribed to our channel, don't forget to subscribe to get the latest notification about what all we are going to do. So today we are going to discuss about electric charges and field chapter, as you can see. And from that chapter we have divided it into 2 parts. In the first part we are going to discuss basic properties of charges. Okay, some common concepts about charges, basic properties of charges. We will also discuss about electric field, and we will also discuss about field lines. So if you are wondering what all we are going to discuss, let's see the detailed topic list. Electric charge, conductors and insulators, basic properties of charges, Coulomb's law also be discussed, then electric fields and electric field lines. Now remember, we are not going to discuss each and every concepts. We will only discuss important KCET concept, and whatever is relevant to learn those concepts, that will be discussed. Also, we will see some previous year questions while studying this chapter, so that you are familiar what type of concept, what type of question is coming from this chapter. So let's start with the electric charge. So let's look into the basic things about electric charge. There are 2 types of charges, right? What are those? Positive charge and negative charge, right? So there are two types of charges, positive charge, negative charge, and like charges repel each other. Okay, so that means if we have say a positive charge, we said there are two types of charges, positive charge and negative charge, and we have say two positive charges, they will repel each other. What is the meaning of repel? Repel means they will say, hey, you are positive, go away, go away. So they will apply force on each other in the opposite direction. Okay, that is the meaning of repulsion. So if I am positive, someone positive comes near me, I will say, go away, right? So you know there is a very huge joke about it. During COVID pandemic, people were saying if positive and negative repel attract each other, then that's why the COVID is spreading. Okay, that was a very common joke. So similarly, if there is two negative charges are there, okay, they will repel each other. Okay, so positive and negative, they repel, positive charges repel another positive charge, negative charge repel another negative charge, but unlike charges attract each other. That is the joke about in COVID. So unlike charges attract each other. What is the meaning of that? So if you brought a positive charge near a negative charge, they will attract each other. Similarly, a negative charge will attract another positive charge. Okay, so positive charge will attract a negative charge, and negative charge will attract a positive charge. But in between two positive charges, they will repel each other. Attract means basically attraction and repulsion are forces. We'll study about forces in our Coulomb's law part, where we are coming to the Coulomb's law part, but you should know that attraction and repulsion are forces. So they will apply force on each other. Okay, and like charges, they will repel, unlike charges, they will attract. Now, in a neutral object, what is the meaning of neutral object? A neutral object means where net charge is 0. So apparently it does not have any affinity, does not attract or repel any other things. That's why they are called neutral object. Okay, a neutral object, positive and negative charges are balanced. So if I say there are some units of negative charges here, okay, then there will be same measurement of the positive charge as well. So if this is positive charge, this will be negative charge. So they will balance each other. If you put them on a balance, they will be equal and opposite. Okay, so that's why total charge in a neutral object is 0. So neutral object has 0 charge because not because they are void of any charges, they already have charges inside them, but positive and negative charges are equal and opposite, so they balance each other, they cancel each other out. Okay, but they are not void of charges. You should remember this point. Now, what else? To charge a neutral object, we need to add or remove one type of charge. So basically, what is the meaning of that? When we have a neutral object and I want to charge it, okay, so I want to charge it, only one type of charge can be added or removed. So previously we learned that there are two types of charges, positive and negative. But even if I want to charge it positive, or even if I want to charge it negative, only one type of charge I can exchange. What that charge is? That charge is electrons. Okay, only electrons can be added or removed. Now what is electron? What is an electron? Electrons are negatively charged, right? We know all these things. Still we are doing a refreshment. So electrons are a negatively charged object, and if electrons are added to a body, what will happen? Excuse me. If electrons are added to a body, I have some electrons here. Okay, electrons are represented by a symbol E minus, right? So electrons are added. What charge they have? They have negative charge, right? So they have negative charge. This negative charge you add to a neutral object. So this neutral object will become negatively charged, obviously. So if you add negative charge to something, it becomes negatively charged. And if electrons are removed, the body becomes positively charged. So initially it was neutral. Initially, let us consider another object. It was neutral object. Okay, so in the neutral object, it has some positive charge and some electrons. Okay, total charge was 0. Now, if I remove this electron out of the body, then this object will become, this will no longer be zero charge, it will be positive charge, right? It will become positively charged. So, if I add electron, it becomes negatively charged. If we remove electrons, it will become positively charged, right? So, adding electron negative, removing electron positive. Okay, here we have removed the electron. So, you should remember, this is very basic fact. Next is how we can detect the presence of charge. So, I say this is a charged object. How I can detect this is a charged object or not? So, for that we use a device called gold leaf electroscope. The picture is given here. It's a representative image, obviously not real gold leaf electroscope. Electroscope basically has two gold leaves, a very thin paper of gold. Okay, so that is hanging here. And when you brought a charged object, these leaves, they repel each other, they move in the opposite direction, giving you a sense of opening. Okay, so it's like an opening, so that gives you a sign, okay, this object is charged. If nothing happens, that means that object is not charged. Okay, next is SI unit of charge is Coulomb. Okay, so Coulomb is the SI unit. And while you are writing the entire term, if you write with C small letter, that gives you Coulomb unit of charge. If you write capital C, that gives you the name of the physicist, name of the researcher that we know today, Coulomb's law. So that is based on the name of the Coulomb, scientist Coulomb. Okay, and with small letter C, it is the unit of charge. Okay, the dimension of Coulomb, dimension of charge is current times time. Okay, dimension of current multiplied by dimension of time. So that is the dimension of charge. Now, if you know why this is dimension of current times dimension of time, you can mention that in the comment below. Why this is A times T? Okay, why not something else, right? So it is also means that M times 0, L times 0, A times 1, T times 1. Now, in general, this is the way some books write their dimensions, but there are 7 total fundamental quantities. There are 3 more fundamental quantities. Why we are not writing that? Why we are focused that M is 0, L is 0? So that's why this is also fine. This is also a dimension, but sometimes they will ask you in like this in the question paper. So be careful. This is also a way of representing the dimension for current, charge. Now, conductors and insulators. Now, based on whatever we have learned, that charges, based on how the charges behave, there are 2 types of material that we can define. One type of material is called conductors. And what are all those conductors? Conductors are those through which charges can freely move through them. So, if charges are allowed to move through them freely, then they are called conductor. A conductor has a lot of free electrons to carry electricity. So, in our day-to-day life, whatever things that we are using, for example, this light is glowing because I have switched on the switch. So, light is glowing because as soon as I switched on the switch, so the current passes through that wire and reaches the light. Now, that wire is actually carrying the current, right? So, that wire has to have become a conductor, right? So, that wire is a conductor, that's why it is carrying electricity from the switch to the place. Similarly, the power is generated 100 and 1000 kilometers away. So, where there is a hydroelectric dam, or there is a coal power, or is a hydro power or solar power, whatever it is. So, that is 1000 kilometers away. From there, the electricity is reaching to our house. So, how it is reaching? Because high tension cable which carries the wire current from there till our house is connected. This is a conductor. So, conductors are also very, very important. Some examples of conductors are metals and graphite. Here there is a image of cross section of conductors. Now, conductors, remember that conductors have lot of free electrons. Now, these free electrons always reside inside the conductor. Okay, so whenever you consider a conductor a neutral conductor, when the conductor we say it is a neutral conductor, if the conductor is neutral, all the electrons, okay, stays inside the conductor. If I consider an conductor, say wire, suppose this wire I am drawing in like this. So this wire has a lot of free electrons. These free electrons help us to carry electricity, right? That is the fundamental thing, and sometimes it is called sea of electrons. Sea. In a sea there are numerous amount of water molecules. Similarly, in a conductor there are numerous amount of electrons. That's why sometimes it is called sea of electrons. Okay. So now in this sea there are a lot of negative charges, but these negative charges cannot come out on their own. So suppose if I give this conductor was by default was neutral. So all the charges inside this conductor was 0. Now if I give it some charges, some external charges, say some electrons I added by default from outside. Now these all electrons will stay on the surface of the conductor. No matter where you add it, suppose you take a wire and dig it and put it inside the conductor, they will all float and come out on the surface of the conductor. They will no longer stay inside the conductor. So any excess charges will always remain on the surface of the conductor. Remember that. So for example, if you take a ball, okay, a plastic ball, you go to a you take a bucket of water and you take that plastic ball, put it inside the bucket of water. What will happen if you release the ball? As soon as you release the your hand, the ball will come out on the surface and start floating on the surface. Similarly, any charges given to a conductor, they start floating on the surface of the conductor. You can consider this conductor as water and the charges as plastic balls. They will always float on the surface of the conductor. Okay, there will be no excess charge. Remember, excess charge, I am saying excess charge. Okay, there will be charges inside, but the positive and negative will cancel each other. They will balance each other. But any extra charge that you give, maybe positive or negative, okay, that charge will always reside on the surface of a conductor. The same thing is not true for insulator. For insulator, if you give it charge to some point A, that charge will stay at that point. Whereas for conductor, it will come out on the surface. Now, next part is insulator. Charges cannot flow through the insulator. Charges will, as I said, if you give charge at some point, the charge will stay at that point and it will not flow on its own. They have almost 0 free electrons. So they by default, they do not have any free electrons, unlike metals or unlike conductors. Examples are plastic, non-metals. There is one example is here. So this is a high tension wire where the current is being carried, but when it is there is a pole, they are not directly connected to the pole. They are connected via this insulating objects. Okay, so these insulating objects actually disconnect the wire at this point, and there is a hanging part of the wire that is connected from this end to other end, so that the electricity can flow. Okay, but this pole which is used to hang the wire so that the wire does not fall on its own, so that does not connect to the pole itself. Oh, okay, that's why we don't get electrocuted when we touch the electric pole. But do not touch the electric pole on a rainy day, or if you are not sure if this wire is hanging properly or not in rainy days, and maybe sometimes by accident, if this wire touches the electric pole, you may get electrocuted. So but for a general safety reason, they install these insulators, and that's why you don't get electrocuted normally when you are in contact of an electric pole. Now there are another type of conductor, okay, a third type of conductor whose conductivity is in between conductors and insulators. So basically what happened is, sometime it behaves as a conductor, whereas sometime it behaves as an insulator. Okay, so those are called semiconductors. We will learn in detail again about conductors, insulators along with semiconductors in our semiconductor chapter. For now we will skip that part. We'll only know that there is a third material called semiconductors. Now we will look into the basic properties of charges. There are 3 basic properties of charges for your important for your PU board exam, but we will look a little bit detail about that. First is charges are additive in nature. So what is the meaning of additive? Additive means charges can be added algebraically. Okay, so what is the meaning of that? Suppose I gave 3 charges to an object, plus q, minus 2q and plus 3q. Okay, to an object, I have one object, I gave this object first plus q, then minus 2q, and then lastly plus 3q. If I give all these charges to this object, the net charge of this system, okay, net charge of this system is not very rocket sciencey. It is simply adding them, okay, and whatever value you will get, that is the total charge of the system. It is not vectorially added. It is not any complex addition. It is simple addition where we just numerically add them, algebraically add them, and whatever the value. But you have to consider the sign. That is important. Okay. As long as you are considering the sign, you will get the exact charge that is being added. Now, which quantities we can add directly without considering? I give you one hint. For vector quantities, we cannot add them directly. But for other type of quantity, what is other type of quantity? Scalars. For scalar quantity, we can directly add them, right? So basically that proves that charges are actually scalar quantity. So any scalar quantity, you do not need to worry about anything else. You can simply add them one after another. Write down at least 2 more scalar quantities in the comment below. Okay. And more uncommon it is, I will give you a like. If it is an uncommon scalar quantity, I will personally give you a like on that. Now, next property, second property, charges are conserved. What is the meaning of the term conserved? Conserved means if I have something and it does not change with time, it does not change with space, then we say this is a conserved quantity. So it remains constant. If something remains constant over time, over space, then we say this is a constant or conserved quantity. Okay. Now, total charge of an isolated system is always conserved. What is the meaning of that? So, first of all, let us consider a box. Isolated system. It is isolated from rest of the world. Okay, we can consider anything that this box does not need to be a real box. It can be an imaginary box. Okay, for example, I am standing inside this room. This room can be considered as a isolated object. You are watching from your mobile inside your home. So your home can be considered as isolated system. So isolated system means whichever you can separate it from rest of the world for some time, that is called isolated system. Now, I have one object, a neutral object inside this box. Okay, neutral object, it has no charges. Okay, now we can say no matter what is happening outside, we will not exchange anything outside this room. Okay, so as long as this is isolated from the rest of the world, this can be this total charge of this system will always remain 0, does not matter whatever is happening inside. Okay, if the initial charge is 0, it will remain 0 as long as it is inside that box. Okay, similarly, if the charge is greater than 0, suppose it is positive, it will remain positive no matter whatever is happening outside. Okay, that is the meaning of this line. Now let's look into the another property. It is not possible to create or destroy net charge carried by an isolated system, although the charge carrying particles may be created or destroyed. Okay, so in some cases you can create or destroy charges as well, but the total charge will always remain constant. So for example, I am giving you a simple example, not creation, but simple example. I already told you that object contains electrons as well as protons. So for some object, suppose there is an object, neutral object, it has some extra electrons, it has some electrons, okay, not extra, okay, and some positive nucleus. So what I have done, I have taken say 10 electrons from this and taken it outside this object, okay, outside, but it is still inside that box. So what is the charge on this? So the charge, the removed charge or the isolated charge from this object is minus 10e. Okay, minus 10e that I have removed. Now what is the charge of this object? Charge of this object will be 10e. Okay, E is a charge of an electron, right? So I have removed this much amount of this 10 electrons, right? So now these 10 electrons are somewhere here, okay, they are roaming around, but inside this box still has plus 10 charge. Now you might say, sir, initially it has 0 charge, now it has 10, plus 10 charge. How you can say charge is conserved? You have to consider this negative charge as well, right? Now if I say the total charge inside this box, total net charge inside this box plus 10e minus 10e, that means 0. Okay, so total charge of the isolated system will still 0 even after you have separated some charges, you have created some charges. In that case also it will remain constant. Okay, and let's move on to the next part. Charges are quantized. Quantized is a very important term that you must know, must remember, and by heart you should remember what are meaning of that. Suppose you went to a milk shop. Okay, you went to a milk shop and you asked him, milkman, I want 1 glass of milk. Okay, my mother gives me 1 glass of milk every day. I want 1 glass of milk from you. Will he give it to you? He will say, no beta, I only have this packet. You have to buy the entire packet, or you don't buy. Okay, I cannot give you 1 glass of milk. Either I can give you 1 full packet, or I will not give you anything. Right? So basically it is either full or nothing. Okay, it is nothing in between. Okay, half packet milk not available, right? Similarly for charges, there is a minimum fixed value. Okay, so either suppose I want 1.5 packets. How much I have to buy? I have to buy 2 packets. Similarly, there is nothing in between 1 and 2. It is either 1 or 2 or 3. Nothing in between, right? So these are 1, 2, 3. And what is these numbers? These are integer numbers, right? So if something in nature or in real life is actually integral multiple of something, or integer multiple. Integral multiple means when the factor is integer. Okay, integer means whole number, 1, 2, 3, 4. Whole number is slightly different than integers, but for common sense, the whole number and integers are somewhat same. Okay, I know mathematicians and someone who is good in mathematics, they will come and write in the comment, sir, whole number is different than integers, but it's okay. Okay, so integer means when the value is complete number without any fraction, we say they are integral multiples. Okay, free charges are integral multiple of a basic unit of charge that is denoted by E. We know that basic charge is the charge of an electron. So charge of an electron is the minimum value. Okay, this is the minimum value. Now this is only for microscopic level. In macroscopic level we do not consider that, but for KCET this is very important concept. This concept related questions do come in your KCET exam as well as in your PU board MCQ questions also. This is very common question, so you have to remember that the minimum possible value of charge is E. Okay, now what is E? E is charge of an electron, that is 1.6 times 10 to the power of minus 19 Coulomb. Okay, now any charge, suppose I give you a charge, say Q. Any charge of an object, okay, any charge of an object can be denoted by this. Okay, so suppose I remove 100 electrons from an object. I removed 100 electrons from an object. So if I remove 100 electrons from the object, what is the charge of that object? So it will be plus 100 E. So number of electrons removed times charge of an electron. That is the remember that charge of an electron is, we are taking this as magnitude. We are not taking any sign here. Okay, if electrons are removed, then it is positive. Electrons are added. Suppose in another object I took away 100 electrons from one object and I added 100 electrons to the second object. So that will have minus 100E, right? So this is the number of electrons involved and this is the charge of an electron. That is the total charge. that is the total charge. So even if we are saying in most of the cases, for larger cases, we do not actually worry about this value because charge of an electron is very small, as you can see, is 10 to the power minus 19. But for competitive exam, this is very important concept. Also, the concept of quantization itself is very important. Now, let's solve one numerical. I was just talking about numerical. Let's solve one simple numerical. Came in KCET 2014 exam. If a charge on a body is 1 nanocoulomb, then how many excess electrons are present in the body? So it is basically minus 1 electron, 1 nanocoulomb. Okay, minus 1 nanocoulomb. Okay, if charge on a body is minus 1 nanocoulomb, then how many excess electrons are present in the body? So how many extra electron I have given to that body so that its charge is minus 1 nanocoulomb? We know that charge is basically n times E, right? Charge is basically number of electrons added or removed times charge of an electron, right? So what is that number we are trying to find? Now Q is given 1 nanocoulomb. 1 nanocoulomb we will use only magnitude. We are not interested in sign. No matter what sign you will use, you will always arrive at the correct answer. Now what is the charge? Charge is 1 nanocoulomb. 1 nanocoulomb means what? 1 nanocoulomb means 10 to the power of minus 9, right? Equals to n. We do not know what is the charge of an electron. I just said in our previous line that charge of an electron is 1.6 into 10 to the power of minus 19. You have to remember these values, right? These values are very important values. Now what you have to do, you have to calculate the value of n. Okay, so these will come this side as a division, right? This was equal sign was in between. So n will be equals to 1 times 10 to the power of minus 9 divided by 1.6 times 10 to the power of minus 19, right? Now this will go up because this is minus is there, so it will become positive. So 1 by 1.6 times 10 to the power of minus 9 plus 19, right? Am I wrong or right? Now 1 by 1.6 times 10 to the power of 10, right? Now 10 to the power of 10, this number is less than 1, right? 1 divided by 1.5. Anything divided by greater than that number is less than 1, right? So here 1 is here and in division 1.6 is there. So it is less than 1. So what we will do, we will loan 1 10 from this number. Okay, this has lot of zeros. So we will loan 1 0. So 1.6. If I loan 1 0, then it will have 1 0 less, right? So that is 10 to the power of 9. Now 10 divided by 1.6 is, you don't need to calculate this. After this stage, once you reach at this stage, you don't need to calculate, because if you see all the options, 6.25, 10 to the power 27. But is it correct? No, right? Next is 10 to the power of 19. That is also incorrect. Here 6.25, 10 to the power 28. This is also incorrect. Only correct answer is 6.25 into 10 to the power of 9. Even at this stage, if you are intelligent enough, that you will see all the options, all the given options, and you will decide, okay, from all the given option, only one possible that is close to it. So if I do this, I will get 6.25. Okay, 10 to the power of 9. So this is the correct answer. So if you are intelligent enough, from this stage you can answer this. But if you are a fool and if you just read the question and we think, okay, the answer will be this, so definitely that is a wrong answer. I have seen many people after seeing, okay, this value looks like very common, so I can answer this. Okay, so answer should be this. No, answer is this one. Okay, and for that you have to solve. If the question paper is as easy as you think, then they don't need to test your knowledge, right? So you have to be prepared for that. Now, force between two charges, Coulomb's law. So we are now going to learn about Coulomb's law. So what is that? before going to Coulomb's law, we need to learn about point charges. What is point charge? Point charge is size of the charged object is smaller compared to the distance that we care about. Okay, if the size is smaller compared to the distance, then we say this is a point charge. Point means nothing is actually point. Even an electron is not a point. Okay, even though its size is very small, it is in theoretically, mathematically, it is not a point, right? So point charge mathematics means it has no dimension, right? Very small, very, very small. But even if I put one dot, even though you say that this is a point, this is actually not a point, right? Because it has some dimension. But in case of physics, it is a theoretical subject. So we assume that if actual size of the object is much smaller compared to the distance that we are talking about, then we consider this as a point object. So point object, anything whose size is smaller compared to the distance. Okay. Now let us look into the statement of Coulomb's law. The force acting between 2 point charges is given by number 1, directly proportional to the magnitude of the charges. Obviously we know that. And secondly, inversely proportional to the square of the distance between the charges. Okay. And this force acts along the line joining the charges. Everything is known. Okay. Just one formal way of representing everything. And let's look into the law itself. So if we have two charges q1, q2 separated by a distance r, then the force between them is F equals to K q1 q2 by r square, right? That is the Coulomb's law. Here K is called, this part is okay, this part we know, but what we have to remember is K is Coulomb's constant. Okay, here if you see, this is capital C. That means this is not the unit of charge. This is the name of the physicist. Coulomb's constant, and its value is 9 times 10 to the power of 9 Newton meter square per Coulomb to the power minus 2. I will explain how you can remember this unit. This unit is important for PU board. Okay. Second is K is 1 by 4 pi epsilon naught. Now this K was came as a proportionality constant, right? So proportionality constant, but when we did some measurement, we did some calculation, it came out to be a particular value. It is not an arbitrary value. It is 1 by 4 pi epsilon naught. Here epsilon naught is called permittivity of free space. Free space means there is nothing in there. That means it's vacuum. So free space or vacuum are same. So permittivity of free space, and its value is 8.854 times 10 to the power of minus 12. Okay, 8.854 times 10 to the power of minus 12. For all practical purposes, whenever you are solving a problem, you can assume this value is close to 9, unless in some problems, especially in JEE level problems, they give the values as the multiplier of this 8.85. Okay, so 8.85's multiplier is given. Okay, that means 17.5. Suppose the data given is 17.5. 17.5 divided by 8.85, it almost equals to 2, right? So in some cases, if the value is given such that it cancels, then you can use this value. Otherwise, I will teach you, even if this value is given, you can take the closest integer value, that is 9, and then you can use smart calculations and solve numerical problems. Some difficult numerical problems, does not matter. Okay, no matter how difficult problem it is, you can solve it. Okay, some problems are time taking. For example, if you see my solution to question paper 2022, there are some problem are very lengthy. Okay, so that you cannot help. They will give some problem which is lengthy, so that you can adjust that in your time. Okay, now how you can remember this unit, Newton meter square per Coulomb minus 2. Okay, so we know that F is equals to K q1 q2 by r square. So what we are trying to find? We are trying to find the unit of K. So force unit is Newton. We know that from our first year, Newton is the unit of force. K's unit we are trying to find. Now q1 q2 both are what? Both are charges. So charges means, what is the unit of charge? Coulomb. So Coulomb times Coulomb, and R is distance. Distance means meter. That means meter square. Now Coulomb times Coulomb is what? Coulomb times Coulomb is Coulomb square. Meter square is already there. So you can say that K is basically Newton meter square Coulomb to the power minus 2. So this will come down and it will become minus. This will go up and it will become plus. This is the unit for Coulomb's constant. Now if you know this Coulomb constant, how to find the Coulomb's constant? Similarly, you can find the unit of epsilon naught. It will only be reverse. Reverse means Newton to the power minus 1, meter to the power minus 2, Coulomb to the power plus 2. So plus and minus we will exchange. If it was plus, we will make it minus. If it was minus, we will make it plus. Okay, reverse of that. That is the unit for epsilon naught. Even if you forgot, suppose you are writing your PU board exam and this question came, and if you forgot how you remember that unit, you can do it like this. Okay. Now, forces between multiple charges. Suppose we have multiple charges, say one charge is Q1 and there are multiple charges. So one charge is Q2 here, another charge Q3 somewhere here, another charge Q4 here. Okay, like that there are multiple charges somewhere everywhere, and there is a n number of charge here, nth charge. Okay, I am saying this is the nth charge, and what we are trying to find, we are trying to find the net force acting on this Q1. Net force acting on this Q1, how we can find that? We have to calculate all the distances, right? We have to calculate all the distances for all the charges. Okay, say this distance is R12, this distance is R13. So we are trying to find the force on Q1. That's why we are using this kind of symbol R14 like that, and R1n. Okay, and for each pair we can find the force F12. F12 is K Q1 Q2 by R12 square. Similarly, we can find the force for F13, we can find the force for F14, and so on up to F1n. Right? We can calculate all these forces. Now, force is a vector quantity, right? Force is a vector quantity and direction is along the line joining the charges. So, if both of them are, suppose this is positive, this is positive. So, this force will be along this direction. If this is positive, this is negative, this will be along this direction. For each pair, the direction will be different. So, we have to consider the vector notation. We have to consider the vector notation for each of the pair. Okay. So, we have to consider vector for this, vector for this, vector for this. Each pair we have to consider the vector. Right. Now, if you add all these forces together vectorially, then we will get the net force acting on this. So, in formula wise, we can write this in a short form, that is F1 is equal to sigma I is equal to 2 to n F12 or 1I. Okay, so this is the common representation of the force. This symbol is sigma. Sometimes we also call it summation. Okay, so this is a summation symbol or sigma. Okay, whatever you are comfortable with, that is fine. Now let's move on. Now we are talking about electric field. Very important concept. So we are talking about two charges, right? Q, and we are also interested in the finding the force, right? So what is the force between these two charges? The force between two charges is given by K small q capital Q by R square. Okay. Now suppose if we remove this charge, then what will happen? What effect of this charge Q will there? Okay. So is there any effect left there? Let's see in a mathematical way first. So what we will do, we will divide this Q both side. Okay. Then on our left hand side we will see F by capital Q, and on our right hand side we will see K capital Q by R square. Any Q term on this side? No, right? So whatever this term is basically independent of any second charge, right? This term is independent of any other second charge. That's why this should be the influence of this charge, influence of this charge at this point. So this is the influence of any charge at a point is called electric field at that point, and we represented it by E equals to F by Q K or KQ by R square. That is the electric field due to a point charge at a point. So electric field due to a point charge is represented by K Q by R square. Okay, and here this Q is called the source charge. This is the source, this is the primary source for which we are measuring the electric field, and this Q was here, this small q was here as a test charge. Okay, because we took it here, then we removed it. So this has nothing to do with its original field, it is only as a test charge, it was a test subject, it was removed after we measured the force. Okay, so that is one of the way to deal with electric field. Now let's move on. This will be there is a mistake here, this will be capital Q. Okay, now electric field is given by, due to a point charge, is given by 1 by 4 pi epsilon naught Q by R square R cap, right? So here we have used the electric vector symbol and we have used this R cap symbol. What is the meaning of that? So suppose this charge is positive, this capital Q is positive, then what is the force if we keep one positive charge here? If we keep one positive charge here, whatever the direction of force that will act on this, that is the direction of R cap. So if this is positive and if I keep a positive unit charge, the direction will be along this. But instead of that, if this charge was negative, the original charge, it does not matter on this charge, the original charge is negative. Suppose the original charge is negative, then what will be the direction of this force? In that case, the direction of this force will be in this direction, right? So it will get attracted. So in that case, R cap will be in this direction. Okay, so depending upon the sign of Q, whether it is positive or negative, okay, we will accordingly change the direction of R. Okay, the electric field due to a charge Q at a point in space may be defined as the force that unit positive charge would experience if placed at that point. So basically we have now defined the electric field as if there is only one unit positive charge, that force that it experiences when it is kept at a point in that electric field. Okay, that is the basic definition, basic measurement of electric field. Okay, now let's move on. Alternatively, if charge Q instead of unit charge, what will happen if we place a charge Q in an electric field E, then the force experienced by it. So for unit charge electric field is E, right? For Q charge, obviously the force will be QE, right? Q times E. So the force is given by Q times E. Now both of them are vector quantity, charge is a scalar quantity, so you will use vector sign for F and E, but for Q there will be a scalar sign. Okay, now let's look and solve one problem based on KCET 2022 question paper. Okay, a charged particle of mass m and charge Q is released from the rest at in a uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t second is. So there are 4 options are given here. So I will give you a few seconds. If you want to try it, then we will look into the solution. So pause the video if you want to solve it, then solve. If you don't want to pause, don't worry, I will continue with this solution. So first, what is given? The mass is given m, right? And the charge is given Q, right? And the electric field is given E. These things are given. Okay, and what they have asked you to find, electric field is given, but in the final result we are not using direction, so don't worry about direction too much. Okay, neglecting the effect of gravity, the kinetic energy. Now, what is kinetic energy? So, kinetic energy, the basic formula that we remember, energy, kinetic energy, Ek. I am writing Ek. Okay, this is electric field, this is kinetic energy. So, what is the formula for kinetic energy? If you remember, formula for kinetic energy is the basic formula we all remember is half mv square, right? Now, what is this V? V is velocity. Now, how we can relate velocity with this? Okay, velocity is related to other quantity. Which quantity? Velocity is related to acceleration. Acceleration is related to force, right? Force. Acceleration F equals to ma. So now we have to find basically the force. So what is the force? Force is, we know that force acting on a charged particle is Q into E. When kept in an electric field, the force acting on a charged particle is Q into E. Now, from second law of motion, we know that F is equals to ma. A is not given, so we are assuming this as A. Okay, so A is basically Q E divided by m, right? So acceleration is Q E divided by m. Now acceleration is given. Now how we can find the velocity? Okay, there is one more thing is given, that is t second, right? We know that velocity is u plus at, right? Very basic first equation of motion. Now it is said that it starts from the rest. I know most of you are already aware that most of the cases whenever we are applying this formula, we generally use u equals to 0, but it is mentioned it started from the rest. So u is 0, a we have calculated QE by m times t. So V is basically QET by m. Okay, so V's value is calculated. Only thing what you have to do, we have to use this V's value here and calculate the kinetic energy. So half m V square. V square means this entire thing ka square, that means Q square E square T square divided by m square, right? We want to save some time. So this 2 will cancel, 1 will cancel, one of them will cancel. So we will get Q square E square T square divided by 2m, right? This is the solution. Which one is the correct answer? Correct answer is this. Okay, so if you see, they have organized it E square Q square T square by 2m, but if you see, all other options has different values. So this is not correct, only this is correct. Okay, now let's move on. Electric field. Now we are talking about electric field. So before we start, just give you a brief introduction about electric field lines. So the few key points to remember about electric field. Electric field, due to a system of charge, exists at every point in 3-dimensional space. For a positive, so basically it is not a 2-dimensional space, even though we show you a 2-dimensional figure maybe in the books, maybe during our lectures, but still it is a 3-dimensional thing. Okay, so there is something on the out of the paper into the paper that is also exists there. For a positive charge, the electric field will be directed radially outward from the charge, and for negative charge, electric field vector at each point points radially inward. So if suppose I have a positive charge, okay, then all the electric fields will be radially outward. Okay, so basically if you draw them, they will all meet at the center, right? Radial means you have to draw the radius, then it will be outward. Okay, so basically it's for positively charged object. Okay, it will be, so what is the meaning of radially outward? That means this is tangent. This, if you draw the tangent, it will be 90 degree. That's it. Okay, same for negative charge. Positive charge, the direction is outward. From negative charge, the direction is inward. That is the difference. Okay, now electric field due to a point charge is spherically symmetric. If the charge is point, okay, then if you draw a sphere, okay, all the point on the sphere will have same electric field, same value of electric field. We will see that in Gauss's law, but still you should know that when charge is point, it is spherically symmetric. So basically all the points are same distance, right? So distance r. Since the distance is same, all points on the surface of the sphere are equidistant. Okay, so we can say this is symmetric. Spherically symmetric. Spherically symmetric means all point has same value of electric field. That's it. The spherically symmetric means same value of electric field. Now, when a positive charge is kept inside an external electric field, it experiences a force in the direction of electric field. So, if you keep a positive charge in some external electric field, this positive charge will experience a force in the same direction of the electric field. Okay. Similarly, when a negative charge is kept, suppose now you in the same electric field you kept a negative charge. Okay, it will experience a force in the opposite direction of the electric field. So, this will experience a force in the opposite direction. So, electric field is in this direction. This is the direction of electric field. Okay. So, electric field is in this direction. Positive charge will move in the direction of electric field or experience a force in the direction of electric field, and negative charge will experience a force in the opposite direction of the electric field. Okay. Now, electric field due to a system of charges. Now, if we have multiple charges Q1, Q2, okay, Q3, Q4, such that Qn, and you want to find electric field at some point, say P, what you have to do? You have to join all the points and find the individual electric fields. Same way that we have done multiple charges for electric force. Okay, here the point is lonely, point is alone. In that case, we had at least one charge. But here what we are doing, we have this point, this is our hero point where we want to find the electric field. We have to find the electric field in each of these charges, due to each of these charges, direction as well as magnitude, because this is a vector quantity, right? We know that for vector quantity, direction is also very, very important. This is E3. Okay, this is E4. Okay, so mathematically we can write a similar way. Electric field is given by this. Okay, now some properties of electric field lines. Now, before we start properties of electric field line, you should know what is electric field lines. Two things: electric field lines are pictorial representation of electric field. So, we are talking about electric field is radially outward, radially inward. Okay, it moves in the direction of electric field, it moves in the opposite direction of electric field. What is the meaning of that? So, for that we have to represent the electric field in a diagram. So, that is why we use a pictorial representation of electric field, and that we call electric field lines. Now, you should know that electric field lines, if a electric field lines is taken, it will have a direction. Okay, there is a sense of direction, and each and every point, if I draw a tangent to that electric field line, okay, I will get the direction of electric field at this point. Okay, so if I draw a tangent at this point, then we will get the electric direction of electric field at each and every point. Now, if direction does not change, it will be a straight line. If direction change, it will not be a straight line, it will be a curved line. Okay, you should remember these are the very common facts. Okay, now let's look into the properties of electric field lines. First of all, field lines start from positive charge. Okay, obvious, and it end at negative charge. If there is single charge, they may start and end at infinity. So, what is the meaning of that? Suppose I have a positive charge. Okay, it will always start here and it will move towards infinity unless and until there is a negative charge present. Okay, if a negative charge is present, then it will go towards the negative charge. Okay, so from positive charge it will originate at positive charge, it will culminate or end at negative charge, or it may go to infinity as well. Okay, suppose there is no negative charge, then where it will go? This line will go straight to infinity. Okay, similarly for negative charge, if there is no other charge, electric field lines will start at infinity, very far away, and it will slowly move towards negative charge. So, electric field lines move towards negative charge, electric field lines move away from positive charge. That is what you need to remember. Okay, and when it is given in terms of statement, write down the statement. You have to write it exactly like this. In a charge free region, electric field lines can be taken to be continuous curve without any breaks. So, if there are no charges, okay, suppose this positive charge is here, Okay, so there is a positive charge here. Okay, positive charge here, and it has some electric field line. Now, where there is no charge, if I hide this charge from starting from this point till infinity, there are no charges, suppose. In that case, what will happen? We can consider the electric field lines to be a continuous line. Okay, from that point till infinity, we can consider that as a continuous line. Okay, without any breaks, we do not break that line. Okay, next is two field lines can never cross each other, as if they did, the field at the point of the intersection will have a unique direction, which will not have a unique direction, which is absurd. So what is the meaning of that? For example, we say, suppose there is a field line 1, there is another field line 2. So they intersect at some point. Is it possible? So they are saying, by the property of the electric field lines, this is not possible. Why? Because at the point of intersection, I already said that the electric field is actually the tangential line, right? So for this line 1, electric field is in this direction. For line 2, electric field is in this direction. So what will happen? The electric field is a vector quantity. So this will not have neither this line nor this line, but a resultant line, right? If you add them using parallelogram law, you will get a resultant line. So this is the actual field line. So you will neither get this line, you will not get this line, you will get a resultant line which will look like something like this. Okay, which will look like this. Now, electrostatic field lines do not form any closed loop. Closed loop means, what is the meaning of closed loop? Closed loop is nothing but if something is starting somewhere and if they end at same point, then we say this is a closed loop. But for electric field lines, this is not possible. Okay, for magnetic field lines, we will see later on, it is possible. For electric field lines, closed loop is not possible. Okay, it is always started at positive charge and end at negative charge. Okay, so closed loop, if it has to have a closed loop, then from negative charge it will again go back to positive. If that was possible, then we could have said this is a closed loop, but that is not possible. So there is no closed loop possible here. Okay, now electric field in free space decreases as we move in the direction of electric field and vice versa. So suppose we have an electric field like this, electric field like this. If we move in the direction of electric field, the magnitude of electric field decreases. Okay, and if we go in the opposite direction, then that is the opposite to the direction of electric field, the magnitude of electric field increases. So there is a theory that the field lines concentration, whenever the field lines are concentrated, at that point electric field is stronger, and wherever the electric field lines are not so concentrated, electric field is weaker. So that is the another validation of the same point, is that electric field is stronger when the electric field line is closer, and as we move along the direction of electric field, they get separated, decreased by the separation increases by a long margin. That's why the electric field magnitude decreases. Okay, that is one of the point that you should remember. Okay, now let us solve. There are two homework problem I am going to give you that you have to solve. Once you have seen this video, you have to solve these two questions, and without help of any googling or any other thing, you can take help from your books, or you can use this lecture for reference and answer these two questions and mention the answer in the comment below. If you are not able to solve it, don't worry, I will solve them in our upcoming video, that is tomorrow's lecture. I will solve these two homework questions, and don't worry about if you are not able to write these questions down, because I am going to provide you the entire PDF, entire lecture in a PDF format, from where you can see and check these questions. And for that, you have to join our WhatsApp group, where everything will be provided to you absolutely free. So don't worry that you think sir will charge me, how much charge I have to pay. Nothing, zero, everything is free. You just have to join our WhatsApp link. The link is down below. So don't worry. And if you are seeing this video for the first time, don't forget to subscribe to our channel. And if you think this lecture has improved your physics, don't forget to give it a thumbs up. Thank you.